Is there any question before we go to example number 2? Example number 2. We are together, right?
Yes.
Okay.
Yes.
Let's go to example number 2. Example number 2. The question is this. It's not on in the notes, eh? I'm going to read for you, okay? Given that vector P is equals to 6 and 12, Q is equals to -4 and 2, and C is equals to 26, 32. Are you together?
Yes.
Is find the scalar K. Find the scalar K if if 3P plus KQ is equals to vector C. Is it okay?
Yes.
Have you put the question down?
Yes.
Okay, let's work it out. Solution. Let's look at the solution now. So this time they've given us vector P, they've given us vector Q, and they've given us vector C. Now they want us to find the scalar K using the condition they've given us. Using the condition. The condition is what? 3 vector P plus KQ must be equals to vector C. So how many operations are involved in that question? How many operations are there? Or are we going to find vector? How are we going to find the scalar K? Are we going to find the scalar K? Members, what are we going to do? So we are going to say we have 3, not so? 3 into vector P, which is what? 6 and 12, right? Are we together? Plus K, which is the scalar, into -4 and 2. Everything must give us vector C. What is our vector C? Our vector C is 26 and 30 and 32. Is it together, members?
Yes.
So in this question, how many scalars do we have? How many scalars do we have? In this question, how many scalars do we have? Which one and which one?
Yes.
We have 2 scalars. Which one and which?
3 and K.
3 and K.
But now we want to find the scalar K. Good. Is 3 and K. Good. So can we expand this? When you take this one inside there, what do you get? 3 times 6, what do we get? We get 18, right?
18.
Then 3 times 12, what do we get? 30?
36.
36 plus, now we have to take this K inside. When you take K inside, what do we get? We get -4. -4K.
-4K.
Then we get 2K. Not so? Equals to
Yes.
26 and 30, 32.
32.
When you look at the left hand side, in the left hand side, what are we doing in the left hand side? Which operation are we dealing with?
Addition.
How do we add vectors? We said, how do we add vectors? We add corresponding
Components.
which means we have 18 plus -4K. Not so?
Yeah.
Then 36 plus
36.
2 plus 2K
2K.
equals to 26 and 32. So when we simplify that one further, integers, so we shall have 18, negative and positive will give us?
Negative.
So it will be -4. minus 4k, right?
Okay.
Then 36 plus 2k. Everything is equals to 26 and 30 and 32. Do we stop there? Do we stop there, members?
No.
No.
What do we do? We want to find k. So what do? Equating corresponding, we equate the corresponding elements, okay? Equating corresponding elements or components. Are you together?
Yes.
So, which means 18 minus 4k must be equals to 20.
26.
Or 36 plus 2k is equals to 30.
32.
So any of these two equations must give us the same value of k. Are you together?
Yes.
So taking, which one are we taking? Taking 18 minus 4k equals to 26. Okay? So what do we do there? We collect the right terms. Not so?
Yes.
So shall have negative 4k equals to 26 minus 18. Is it true? Members, is it true?
Yes.
Yes.
Then negative 4k is equals to 26 minus 18. What do we get? If you are not sure,
8. So it's 8.
you pick your calculator, which will give us 8. Not so?
8.
Yes. I said, if you are not sure, pick your calculator, okay? If you are not sure, pick your calculator. 26 minus 18. Ready? Have you pressed yours? What do you get? Mine is 8. So divide all through by negative 4. Divide all through by negative 4. Negative 4 and negative 4, natural death, not so?
Yes.
So we remain with our k equals to, what is the answer?
Negative 2.
So divide by negative 4, we get negative 2. Are you together?
Yes.
Now you prove your work. Is it true that when you take the second equation, do you also get negative 2? You try it out. Work out that. I want to see it. Work it out too. Work it out. Prove that one. That one is your work now. Prove it.
So yeah, I'm done.
Is it true that you get negative 2?
Yes.
Members?
Yes.
You get negative 2, right?
Yes.
Very good. Very good. Very good. Number 3. Let's go to example number 3 now. Number 3. Okay? Can we move to number 3?
Yes, it's correct.
Members, can we move to number 3?
Yes. Yes.
Okay, the question is not in the notes. So given that vector P is equals to 2 and 0. Vector P is 2 and 0. Q is equals to 0 and 3. Okay? And C equals to 6 and 6. Okay? Full stop. Full stop. Find scalars. Find the scalars K and M. Find the scalars K and M. such that KP plus MQ equals to C. Have you seen that? Have you seen that question, members?
Yes.
So when you look at this question and the previous one, are they the same? Are they the same?
Yes.
So in this case, how many scalars do we have? We have two,
Scalars.
Scalar.
K and
M.
K and M.
now they want us to find those two scalars. Let's see, how do we find them? Solution. Let's go to the solution. So they want us to, we have KP, MQ equals to vector C. So when you substitute, so we shall have K into, in natural, what is our P? In natural, what is our vector P? In
2,
natural,
0.
2 and 0, plus M, what is our vector Q? Bernard, what is vector Q, Bernard? Bernard, what is vector Q? Is 0 and 3. Good. Equals to, what is vector C? Cynthia, what is vector C? Cynthia.
0.
Cynthia, what is vector C? Cynthia, what is vector C? Is it 6 and 6? Good. So what do we do? What would be the next step? What would be the next step? The next step is to multiply the vector with the scalar, right? So here we get 2K, right?
Okay.
0, right? Someone may say 0K. Who is that one? Plus. What do we get here? M times 0. What do you get?
0.
I thought maybe you get. I thought maybe you get M0.
No.
Okay. 0. What do we get? This one will give us 3. M equals to 6 and 6. So still considering the left-hand side, we are adding the two vectors. We are adding two vectors, right?
Yes.
So when we add them, we shall have 2K plus what?
0.
Then
Plus
0.
0.
Then 0 plus 3, M, which must give us 6 and 6, right?
Yes.
Don't jump steps. Mathematics is all about the steps, because the more the steps, the more marks you earn, okay? Right, together?
Yes.
So 2K, we get 2K there, then we get 3 what? 3M equals to
3M.
6 and 6. Yes, Beatrice, what next from there? What do we do from there now? Because we want to find the value of K and M.
We equate corresponding elements.
Corresponding element, which means 2K will be equals to
6.
Will be equals to 6. So what do we do there? What is K?
Divide.
So K is it? Our K is it?
3.
Also we have 3M equals to 6. So we divide all through by 3. So what is our M?
2.
Our M is
2.
Our M is 2.
2.
Is it okay?
Yes.
All right. Then last example, then we move to another concept. The last example on operation of vectors, then we move to another concept, okay? Number 4. And this one, you are the one going to do it, okay?
Yes.
So can you write the question? Can you write the question down? Write the question down. Given that given that vector A is equals to 15 and negative 20, 15 and negative 20, and B is equals to 7, 24, comma, find 2A minus 3B. Work out that. Work it out. I'm waiting for the answer. Members, is it okay?
Yes.
Yes, I'm waiting for the answer. What's finished? What's finished that one?
Not.
Huh?
So we are still.
You are through, eh?
Not yet.
People are taking years.
No.
Improve on your speech. This time, who is going to tell me what to write? I'm just waiting. Who is going to tell me what to write?
Done.
Give me what you have got. Tell me the step by step. What should I write? What should I write? That person was finished. Who is that one?
Miriam.
Patricia, you did not say anything since morning. Can you say something now?
Okay.
Patricia,
You write into brackets.
2 into
15 and negative 20 minus 3 into brackets 7 24.
That is good, Patricia. The next step.
Then after that, you multiply the 2 by all
Elements.
elements in the brackets.
What do you get?
30.
Good.
Negative 40.
Negative 40. Members, are you following Patricia? Are you following what Patricia
Yes.
is? Good. Minus into
Brackets 21.
21.
62.
60.
62.
72.
72.
Yes, Patricia.
Yes.
Can I ask you?
Yes.
Why not putting negative 21 inside the bracket? Why not putting negative 21 or negative 72? Because there's a negative here. There's a negative here. Why are you not putting the negative there?
We have to maintain that negative. It's not part of the color.
Excellent, Patricia. Excellent. Good. Continue. Then we shall have 30 minus.
That's 21.
Then negative 40 minus.
40 minus 72.
Okay. What do you get now, Patricia? What do you get? The final answer?
you get 9
and
negative 112.
negative 112.
12.
Do we all have that?
Yes.
Yes.
Can you appreciate Patricia? Really? Can you appreciate that, please?
Thank you, Patricia.
Yeah, Patricia, thank you. Thank you so much.
Thank
Yeah.
you.
Ready? Ready? Ready?
Yes, teacher.
I didn't hear you appreciating Patricia. I didn't hear you. Can you appreciate Patricia now?
Thank you, Patricia.
Very good. Very good.
Welcome.
That is the operation on vectors. Is there any problem on that? On operation of vectors before we proceed?
No.
Okay. Our next heading is the magnitude of a vector. Subheading, magnitude of a vector. Magnitude of a vector. Magnitude of a vector. Magnitude of a vector. Yes, members.
Yes.
When we talk of a magnitude of a vector, we mean the size of that magnitude. I mean of that vector, okay? We mean that's the size. But now, we are saying that if we have a vector A, which is given by x, y, okay? Which is x, y.
Yes.
Then the magnitude of that vector is denoted as the notation we use is A. I think that one. This one means when you see this symbol, these two bars, this one is standing for the magnitude of vector A. Are you together?
Yes.
Yes.
So when we write like that, this one is standing for the magnitude. Is standing for the magnitude. Are you together? Then the next question is, how do we get now the magnitude? If we know how to write it, how do we get it? So the magnitude of a vector, which is that, is given by a square root of x squared plus y squared. Is it okay?
Yes.
Now, someone will ask me, hey teacher, where is that formula coming from? It's not a wrong mathematics to write that. The mathematics is, I'm now going to explain for you. Are you seeing that diagram there, the Cartesian plane?
Yes.
Consider x and y.
Yes.
Consider x and y axis. I'm drawing mine. You also draw yours. I'm drawing mine. You also draw yours. If I have a point A, a point what? A. Let's assume that that point A is at that point on a plane. On a what? A plane. And that vector OA is defined by vector A. Is defined by vector A. Okay? So this is our origin. So we know that we said our coordinates help us to determine the position of a vector. So if we have A, which is xy, we are just using, this is a general example. This is a general example. So to allocate that point, that point, we need to move x direction. We start by moving x. Which means the distance from here up to here is what? The distance from here up to here is it? What is that distance? Remember, the distance from here up to here is what? From here up to there is what? It's x, not so. Not so? Then from here up to here is it? That distance is it? Is y. That distance is what? Is y. Now, and then this one, OA is represented by vector. Is presented by vector what? Vector A.
Vector A.
So when you look at this diagram, what is this figure? What is this figure? What figure are you seeing here? Which figure are you seeing there?
Triangle.
Is a right angle? Is a right angle
Right
triangle?
angle triangle.
So therefore, if I want to find the magnitude of this vector, I use what we call Pythagoras theorem. Pythagoras what?
Theorem.
Theorem. So
Theorem.
this is our extract. Our extract, it looks something like this. Something like this. This is our extract. This is our extract. This was our point O. This was our point A. Okay. Then the distance from here was X. Then here is Y. Then here is what? A. I think that. I think that.
Yes.
Then using Pythagoras, using Pythagoras theorem, which is defined by c squared equals to a squared plus b squared. Not so? Not so?
Yes.
Yes.
C is the longest side of a triangle, which is represented by a. Not so?
Yes.
Yes.
So it implies that a squared now is equals to So our a is going to be our x. We're going to take this one as our a. So this is c, this is a, this is b. Okay.
Yes.
So a is what? A is what? X, right?
X.
Yes.
So this one become x squared plus what is our b?
B
Y
squared.
squared.
So it become y squared. So now if I get the square root now, I'm getting the magnitude of a because this is presenting a. I think that because I want to find we said the length. The length of that line determines a magnitude of that vector. Do you remember that when we are introducing vectors?
Yes.
Yes. So which means if I get the square root on both sides, I get the square rooting both
Sides.
sides. So if I find the square root, which means now I will remain with a, not so. A equals to the square root of x squared plus y squared. Are you seeing that?
Yes.
But when you just write like this one, when you just leave it like this, is wrong in vectors. Are you together? In vectors, this one is wrong. So to make it a magnitude, so we put this symbol there. Okay? We put that symbol like that. Okay? Which now it becomes equals to x squared plus y squared. Have you seen that? Have you seen that, members?
Yes.
Yes.
That's how the formula came all up. That's how the formula came. Can we move now? Can we proceed? Can we proceed?
Yes.
Yes.
So if they ask for the magnitude of a vector, the formula is there. This is the formula. This is the formula, okay? Then, before we move, remember these lines. If we are using a graph paper, Paper, okay? If we are using a graph paper, then we would be in position to count the number of squares to determine the length of this. And remember that each square is a unit. Each square is a what? Is a unit. Are you together? Each square is a what?
Unit.
Is a unit. So which means after getting the answer here, after getting this answer here, then you'll write the word units because it will give you how many units should you move. You should move from a point, from that point to the next point. Are you together? Are we together?
Yes.
Yes.
Good. Just a minute. Yes, members. Are we together on that? Are we together on that?
Yes.
Let's move to the example now. Example. The question is not on the, is not in the work we are having there. Okay.
Okay.
The question is, given that vector A is equals to 8 and 2, and vector B is equals to 6 and 12. Is equals to 6 and 12. Is equals to 6 and what? And 12. Okay.
12.
Find
Yes.
Roman 1 magnitude of vector A. Okay. Magnitude of vector A. Then Roman 2 magnitude of vector B. Okay.
Yes.
Then Roman 3 is magnitude of vector A plus magnitude of vector B. Okay. Is it okay?
Yes.
Yes. So let's work it out. Solution. Solution. Okay. Let's start with Roman 1. In Roman 1, they want us to find the magnitude of vector what? Vector A. Members, are we together?
Yes.
Yes.
Recall. So we say that to get magnitude of vector A is the same as is what? X squared plus Y squared, right? So which means it implies that the magnitude of vector A in this case will be the square root of what is vector A? What is vector A? Is 8 and
8 and 2.
so what is our X?
12.
What is our X? What is our X?
Yes, come on.
What is, our X is 8. So 8 what? 8 squared plus what is our Y? Our Y is it?
2 squared.
So it become 2 squared. So if that is true, which means magnitude of A will be equals to the square root of what is 6 squared? I mean 8 squared. 8 squared, what do we get?
64. 64.
We get 64. 64 plus
4.
plus 4. So magnitude of A and B become the square root of 64 plus 4. We get 68.
68.
So if you are not sure, you can leave it like, but when you press your calculator, what is the square root of 68? Square root of 68. Are you seeing that? Eh? What is the square root of 68? Is
8.25.
8.25 units. I said after getting your food, what? Units. Are you together? Members?
Yes.
Is that okay?
Yes, teacher. Yes.
So after calculating for magnitude, whenever you are calculating magnitude, don't forget to put units. Are you together? Don't forget to put what?
Yes.
Units.
Do for me part B. Do for me part B. Do for me part B. I mean part 2, sorry. Who has finished? Who has finished that one? In B, in Roman 2, they want us to find magnitude of B, right? That's how you write it. I think how you are writing. Yes. Let me know if everyone is writing this. So what do we get? Will be equals to the square root of
X squared.
x squared
6.
plus y squared, not so. Equals to the square root of,
Yes.
which is it?
6.
6 squared plus 12
12 squared.
plus 12 squared. What do we get? We get 36
36.
plus 140.
44.
When you add that one, what do you get? 36 plus 144, what do you get?
180.
Is what?
180.
Is 180.
180.
So what is the square root of 180? The square root of 180. I think how you should press it. Square root of 180.
Yes.
Yes.
What do you get? We get 13.
0.42 units.
So therefore,
2 units.
so magnitude of B will be equal to 13.42
42 units.
units. Are you together? All right. Now Roman 3. Roman 3. Roman. In Roman 3, we have, they want us to find magnitude of A plus B, not so?
Yes.
So the first step is, the first thing we have to get A plus, vector A plus vector B
A
first.
plus.
Okay? So what do we get? What do we get? Is 8 and 2 plus 6 and what? 6 and 12, right?
Yes.
So what do we get? So 8 plus 6.
14.
Then this one. What do we get? 14 and
14.
14, right?
And 14. Yes.
Can you get for me the magnitude now? So the magnitude of A plus B will be the square root of x squared plus y squared, right? So A plus B equals to, what is our x? Our x is what? 14, right?
Yeah.
Yes.
Come 14 squared plus our y is also 14 squared.
Squared.
Okay?
Yes.
So what is 14 squared?
196.
Is 196.
6.
196 plus 196, what do you get? 196
392.
plus 196. You get 392. 92. So what is the square root of that? Therefore, A plus B is equals to the square root of the answer. The square root of the answer is it? 19.
19.8.
19.7. 19.8. Good. It's 19.8. Okay. What?
Yes.
Units.
Units.
Was not understood. Was not understood. We have all got, right?
Yes.
Yes.
All right. So that's how we get a magnitude of a vector. That's how we get a magnitude of a vector. Now let's come to this example you're seeing on your screen, the one I'm highlighting. I think the one I'm highlighting.
Yes.
Yes. Put that question and do it. Put that question.